Hello there. As you can see, I've titled this video, How to Understand Equations. And that may seem like a really vague and big and ambitious subject for a video, and it kind of is. So let me maybe lower your expectations a bit and explain what I'm trying to do in this video and why I'm making it. A while back, somebody left a comment on one of my other videos that I'd made, asking if I'd make some videos about how to read and understand difficult mathematics expressions and equations and understand the meaning of it, what exactly it's trying to say, and how to solve it. And my first reaction was, well, that's a good question or a good suggestion, but it's a really big one. That's way too big for just one video. I mean, there are lots of different kinds of expressions and equations and lots of different methods for solving them, and they come up in all sorts of different branches of mathematics and other subjects that use math. And I've already made some videos about solving specific kinds of equations, specific techniques for solving certain kinds of equations. But the more I thought about it, I thought maybe there are some things that I can say in general that some people would find helpful about, in general, what to do when you encounter an equation and you're trying to figure out what it means or what to do with it, what to look for. So that's what I'm going to try to do in this video. I'm going to try to give a few suggestions about what to do with equations or what to look for in an equation, how to understand what it's trying to tell you. And my first suggestion is pay attention to where the equal sign is. That's probably the first thing I look for, or the first thing that jumps out at me when I see an equation. It's got an equal sign in the middle of it somewhere, and I need to keep track of where that is. After all, the equal sign is what makes an equation an equation. An equation is a statement that one expression is equal to another expression, that they have the same value as each other. So every equation consists of three parts. You've got an expression making up the left side of the equation, you've got the equal sign itself, and you've got the expression making up the right side of the equation. And that expression might just be an individual number, it might be more than one number added or subtracted or multiplied, it might be some really complicated algebraic expression. But what I've seen some people get confused about, some beginning algebra students, they lose track of where the equal sign is. And things that were supposed to be on one side end up on the other side. So the equal sign in an equation is a little like the net in a game like tennis or volleyball. You want to make sure each team, each set of players stays on their own side of the net and they don't stray across the net to the other team's side. So here are some examples of things that are equations. 1 plus 2 equals 3. 7x minus 1 equals 20. X plus y equals 13. They all say that one thing is equal to another thing. And now here are some examples of things that are not equations. 5 plus 3 equals... It just leaves you hanging. It's not a complete equation because it doesn't have anything on the other side of the equal sign. 5x plus 35. That's an expression, but it's not an equation. It's not saying that something is equal to something else. And of course, this is not an equation, it's a chicken. And this is something that I see sometimes on social media or even in news articles that really should know better. They talk about something like an expression, but they refer to it as an equation. So like something like 6 divided by 2 times 1 plus 2, that's not a math equation. There's no equal sign in it. It's not saying that something is equal to something else. It's just an expression. And so sometimes people develop misunderstandings about what equations are or about what the equal sign means. And one common misunderstanding is to think of the equal sign as a do something operator. So maybe people get this idea when they're children learning math and they encounter problems like 5 plus 3 equals, and they interpret the equal sign there as saying, okay, now what's the answer? What is 5 plus 3? Or using a calculator. A lot of calculators are set up so that pressing the equals button is how you get the answer, how you tell the calculator to go ahead and perform the calculation. You punch the buttons 5 plus 3 equals, and it tells you what that is. And sometimes people will use what's I've seen referred to as a running equals sign, like if you have a bunch of numbers to add together, and so you write something like, well, 5 plus 3 equals 8, plus 1 equals 9, plus 10 equals 19, and so on. And when I look at that, I see things like 5 plus 3 equals 8 plus 1, which is not true. Or 8 plus 1 equals 9 plus 10, which is definitely not true. 8 plus 1 and 9 plus 10 are not equal to each other. And so this is something that, from what I've seen online, is more of a problem in the United States than it is in some other countries. Maybe because of the way math is taught in the early grades in the United States. But it can cause confusion when students get to algebra and they really do work with equations. And they're confused about what the equal sign in an equation really means. And as a tip, when you're solving an equation and you're going from one step to the next, you may want to keep the equal signs lined up directly above one another. So there's nothing wrong with writing something like this. So you have the equation 3x minus 2 equals 16. You add 2 to both sides, divide both sides by 3, and get your solution. But if you can keep track of that, you don't have to line up the equal sign. But some people find it helps them to keep track of what's on the left and what's on the right if they always put the equal sign in the same place. And I've even seen some beginning algebra students draw a line through where those equal signs are to make it really clear what's on what side and what's on the other side. So this is mainly for beginning algebra students. If you're a lot more advanced in math, then probably you've gotten used to this and you're real familiar with how equations work and you don't need to worry about this so much. But for beginning algebra students, I've seen this enough that I really would caution you to keep track of where the equal sign is and who is on which side of it. And notice what I did in the first step of this equation. I added 2 to both sides. And so that's the kind of thing that you sometimes do when you're solving an equation. You want to get rid of that minus 2 so that the 3x is all by itself. So you add a plus 2 to both sides. But what I've seen beginning algebra students do more often than you might expect is they get careless, and instead of adding 2 to both sides, they add the same number twice to one side. So they add plus 2 somewhere and then plus 2 somewhere else, but it's both on the same side of the equation, which is of course not legal and doesn't keep the equation balanced. So that's something to be careful of, especially if you're a fairly beginning algebra student. Now let me talk a little about what that equal sign really means. There's 2 kinds of ways that we use the equal sign in algebra. Sometimes we use that equal sign when we want to say that one thing is always equal to something else. An example of that would be an identity. An identity is an equation that's always true. And examples of that would be, if you've studied trigonometry, and if you haven't, don't worry about it, but if you have studied trigonometry, you've seen trigonometric identities, like, for example, that the tangent of x is equal to the sine of x divided by the cosine of x. Now, like I said, don't worry too much about that if you haven't studied trigonometry, but that's an example of an equation that is true in general, not just for some particular x, but for any x. X can stand for any number, and those two sides are going to be equal to one another. And equations with more than one variable that expresses the relationship between those variables, or the quantities that those variables stand for. An example of that would be something like a conversion formula. C equals 5/9 times the quantity F minus 32 is used to express the relationship between the temperature in degrees Fahrenheit and the temperature in degrees Celsius. So if you wanted to convert a particular temperature from Fahrenheit to Celsius, this equation would tell you how to do that. The F doesn't stand for any particular number, although if you do have a particular temperature in mind, you can put that in place of F, and then that equation would tell you that whatever number you put in for the Fahrenheit temperature, then the Celsius temperature is going to be equal to 5/9 times that number minus 32. But the other way we use the equal sign in algebra is when we want to figure out when something is equal to something else. And this is what you're used to when you're solving equations in algebra class. So an equation like, for example, x squared minus 6x plus 8 equals 0. That's not always true. It's not true no matter what x stands for. In this case, it happens to be true only if x stands for the number 2 or 4. So this is an example of an equation where x stands for an unknown number, or maybe more than one unknown number, and we'd want to solve the equation to figure out what that number is to make the equation true. So my second general suggestion for what to do with equations, how to understand them or solve them, is to pay attention to what kind of equation it is. So what do I mean by that? What kinds of equations are there? Well, for one thing, some equations just have one variable, like the one we were just looking at, x squared minus 6x plus 8 equals 0. The only variable in that equation is x. It appears more than one place, but that's the only variable involved. And usually, those are the kinds of equations that we want to solve. We want to find a value or a set of values for the variable that makes the equation true. But if the equation is an identity, if it's the kind of thing that's true in general, we might want to prove it or verify it, or we might just want to use it in something else that we're doing. If an equation has more than one variable, like this one that has C and F, we might want to put it in a different form, rearrange it somehow, maybe get it solved for one of the variables, and this is already solved for C, but we might want to rearrange it so that it's solved for F, and it tells you what F is in terms of C. We might use an equation like that to calculate the value of one of those variables given values for the others. We might want to graph an equation that has more than one variable. Or we might want to understand what the equation is telling us about how the variables are related. Another way to classify different kinds of equations is based on what kinds of values the variables stand for. You're probably used to equations where the variables, the x or whatever, stands for a real number. Maybe any real number, maybe just some sorts of real numbers. But in some equations, the variables could stand for complex numbers involving I. There are equations where the variables are supposed to represent just integers or whole numbers. Those are called Diophantine equations, and you would probably study those in a class on number theory. There are equations where the variables stand for vectors, or matrices, or functions. Differential equations are equations where the unknown that you're trying to find to solve the equation isn't just a number, it is a function. And so you're trying to figure out what function goes in to make the equation true. And then we can classify equations according to, there's linear equations, there's quadratic equations, there's polynomial equations of degree higher than 2, there's radical equations that involve square roots or other kinds of roots of things. There are exponential or logarithmic equations. There are trigonometric equations that involve one or more of the trigonometric functions like sine or cosine. There are, like I said, differential equations. And so the first step in solving an equation is to figure out what kind of an equation it is, because different kinds of equations require different kinds of techniques or approaches to solving them. For example, once you recognize that the equation you want to solve is a quadratic equation, then you know that it can be solved by using the quadratic formula, or by completing the square, or sometimes by factoring. If it's a linear equation, you can solve it by maybe adding or subtracting or dividing the same thing on both sides. But the techniques that work to solve linear equations aren't enough to solve quadratic equations. And then my third suggestion is pay attention to the context in which you find the equation or expression that you're trying to understand. Equations don't usually just come at you out of nowhere. You're not just walking down the street and all of a sudden this equation pops up in front of you. Usually, if you're reading a book or an article that has an equation in it, or listening to a lecture or a presentation that has an equation, it'll come with some sort of context that tells you what it represents and why it's important. The person who is writing the book or giving the presentation should be telling you not just what the equation is, hey, here's an equation, but also what the parts of the equation represent, what the equation is doing there, what it means. For example, you may be familiar with, or at least have seen, Albert Einstein's famous equation E equals mc squared. Now, it's not like Einstein just said, hey, everybody, E equals mc squared. And then everybody said, hey, that's brilliant. Way to go, Einstein. An equation like that isn't really meaningful until you know what the E and the M and the C stand for. Otherwise, it's pretty meaningless. So to really understand and appreciate what that equation is trying to tell you, you have to know that the E stands for energy, the amount of energy, the M stands for the amount of mass, and the C stands for the speed of light. It helps if you know that the speed of light is a very large number, so that number squared is even bigger, and that means that a relatively small amount of mass can be converted into a large amount of energy. And of course, you also need to know the basics of mathematical notation, like that C with a superscript 2 means that you're taking the number C and raising it to the second power. You're multiplying 2 of that thing together. And that happens before you multiply the M. So the C is getting squared, but the M is not. So one thing you have to know when you're trying to understand what an equation or expression is telling you is, what do the letters or other symbols stand for? Now, sometimes they don't stand for anything in particular. You might be just solving an equation for practice solving that kind of equation, and the x in the equation doesn't represent anything in particular. Or you might be studying some particular geometric curve that is the graph of some particular equation. And so the x and y in that equation just stand for the x and y coordinates of the points that make up the curve. But in cases where the variables or the letters and symbols in an equation do stand for something in particular, you obviously want to know what they stand for, what they represent. Suppose I ask you, hey, what's the quadratic formula? Now, if you don't know or don't remember, that's okay. But if you do remember, you'd probably say something like, oh, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's sort of right, except it doesn't really give you any context. If you try telling that to somebody who's never seen the quadratic formula before and never used it, that's not going to be very helpful to them. If you look in an algebra textbook and look up the quadratic formula, it's probably going to say something like this. Suppose a, b, and c are any real numbers with a not equal to 0. Then the solutions to the equation ax squared plus bx plus c equals 0 are given by x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So there it gives you some context for that formula. It tells you that that gives you solutions to an equation of that form. So you use that formula when you have an equation that's set up that way that you want to find solutions to. And the a and the b and the c are numbers. For a particular equation, they would be particular numbers. So the a in this formula stands for the coefficient on the x squared term in that equation. And the b stands for the coefficient on the x term, and the c stands for the constant term. And if this was your first introduction to the quadratic formula, the book would probably go on to explain some more about how to use this formula, how to calculate it, show you some examples of how it works. It would give you some context, and you would want to pay attention to that context. Now, let me end up by mentioning some conventions. So these are not strict rules that everybody has to follow, but these are some usual customs or conventions or things that mathematicians usually do that it might help to be aware of. So letters like X and Y and Z and T are usually used for variables. And in particular, if you have an equation that has both an X and a Y in it, usually the X stands for the independent variable and the Y stands for the dependent variable, the one that depends on the other thing. And if you are graphing that equation, the X stands for the horizontal coordinate of each point on the graph, and the Y stands for the vertical coordinate. So a particular value of X goes with a particular value of Y, and they represent the horizontal and vertical coordinates of a point on the graph, where the point is left to right and how far up or down it is. And the letter T is often used to represent time. If you have something that's changing over time and you have an equation or a function that specifies how that thing depends on how much time has gone by, the T is often used to represent how much time has gone by. It doesn't have to be, but that's a common use for that letter. Letters like M and N are often used to represent not just any real numbers, but specifically integers or whole numbers. So if you see an equation with an M or an N in it, you can't necessarily assume that it has to represent a whole number, but very often that's the way it works. I mean, the person who is showing you the equation should probably specify something like N is a positive integer or an integer or something like that. But it's customary for mathematicians to use those letters in that way. So mathematicians, if you've been around math long enough, you're used to seeing those letters used for whole numbers or integers. And in statistics specifically, the letter N is often used to stand for sample size. That is, how many individuals you have in your group that you are collecting data from. The letters F and G and H are often used to stand for functions. You know, like when you say f of x equals x squared plus 17 or something like that. So the letter F there is being used to stand for that particular function. And a word about the parentheses here. When you're working with functions, the parentheses often surround the parameter or the variable that function is a function of, what it depends on. And that sometimes is confusing to beginning algebra students. You know that parentheses or brackets around an expression are grouping symbols that mean that you're supposed to consider that expression as a unit. But if I put something in front of that expression, sometimes that means multiplication. So 2 in front of this x plus 5 means that you're multiplying together 2 times the expression x plus 5. But f in front of the expression x plus 5 inside those parentheses does not refer to multiplication. It refers to evaluating a function. You're evaluating the function f for x plus 5. You're substituting in x plus 5 for the variable that it's a function of. Greek letters, especially theta and alpha and beta and phi or phi, often stand for angles or their measures. And then in statistics, Greek letters are used for population parameters, like mu, the mean, or sigma, the standard deviation of a whole population, as opposed to just a sample. And while superscripts are usually exponents that tell you what power to raise a number or a variable to, so for example, x with a superscript 3 means x to the 3 power, which means 3 x's multiplied together, x times x times x. Subscripts, where we've got a little number or letter or something below a variable, are usually just labels. They're not operators or instructions to do something. So for example, you might see something like v sub 0, and that doesn't mean to do sub 0 to v. It just means v sub 0 considered all together is a label for something, often the initial velocity in a physics context. So v in general might stand for velocity, and you might be going different velocities at different times, but then you might use v sub 0 to stand for, okay, specifically that's the velocity that we start out at. Or we might use a sub 1, a sub 2, a sub 3, and so on to represent individual numbers in a sequence. If we have several numbers and we don't want to use separate letters for each one, this is A, this is B, this is C, and so on, we could call them A sub 1 and A sub 2 and A sub 3. So this, and really a lot of what I've been talking about in this video, you may think is pretty basic. So depending on how advanced you are in math, this is stuff that, yeah, you already know this, but maybe not. It's the kind of thing that takes a little getting used to for people who are new to it. So in this video, I've tried to give some suggestions for how to understand equations. And like I said, they might be more the kind of thing that's helpful to a beginning math student than somebody who's more advanced. But I would encourage you to leave me a comment or put something in the comments section if you have other suggestions, other hints or tips or things you would suggest for how to understand or deal with or solve equations, or if you still have some questions about what I've been talking about that you'd like for me to answer, or if you have a specific equation in mind that you would like some help understanding or solving or parsing or figuring out what to do with. So I hope this video has been useful. Thanks for watching.